Hello, welcome to a bit of a revisit of an old project we were writing. It's called Advanced Graphics Environment, and it's made as kind of a library for AmosPro. It gives you some AGA style features for just standard Amos. It doesn't do it by the regular way by using an extension structure. I had no idea how to write an extension, and I started writing the library for my own purposes, and I've written a few other libraries similar to it that do very specific jobs for other applications. So what I would do is I would write a tool, let's say in Amos, and if I needed a bit of extra processing power, I would write a plugin in assembly. Now we've got a couple of different builds of the project in here. You can just download it from our forums. I'll give you the link later on, or it's in the description below. Look at AGE version 102. So we have a folder full of examples, just normal Amos files. We'll go start at the start and we'll just work our way through them. Example 1 is a show picture example. So the bare bones of the project is all examples are the same sort of template really. The key point here is we have to include the library and set the path. Now I have this set up to work off DH0, and it expects everything to be in a folder called AGE_V102, and down here as well we need that path to match. This is because the include functionality in Amos seems to only like absolute folders. I couldn't get it to use a relative folder for some reason. If I could have, you wouldn't need this at all, and it would be a little bit easier for people, I guess. But it's just one of those quirks. So we start the library itself. We allocate a bunch of resources for the library users. Pretty complicated stuff. We've got the number of screens, the number of copies we want to use. We've got data banks, or block data, I think that's for. How many banks we want to have, which is just memory banks. How many fonts, file cache size, the kind of cumbersome sort of stuff. But we get down here until the open screen. We open our screen, which is a 320 by 256 8-bit screen. It's a low res and it's an interleaved planar screen. Those people with a bit of assembly programming will sort of know what I'm talking about there. You have our just standard planar, which means each bit field is separate. Interleaved planars means that the bit planes are stacked on top of each other. It's just easier to manage those surfaces because all the memory is in one spot, but they're still in planar though. Anyway, so we're setting up our screen. We're loading a 8-bit IFF to the screen, which is from some demo. It's an excellent picture. I wish I knew who'd made that picture now. Once we've loaded the picture to the screen, we'll create a copper for our screen. Again, a bit more cumbersome setup. This is a bit of an Amos hack. We're trying to make sure our copper shows and Amos doesn't kill our copper. We're setting our all rendering to screen 0 and waiting for a key before we end. Let's check out what we get. A 8-bit 256 color screen in Amos. It's a bit of a yawn, but you know, let's try some other ones. No, don't save that. Example 2, palettes. I don't know what these do, by the way. It's been a long time since I looked at the demo. Okay, we've got the same thing. Alright, we're doing a fade out on the palette. I think we've got some color functions in the library as well. I'll just try and find the function that's doing that. So this demo is pretty much exactly the same, except when we hit space to quit. We're defining our palette. We're doing a fade of all the colours. Yeah, I've got an RGB fade function in here in our library. Doing a weight top of frame to make sure the synchronization's okay. Refreshing the copper. Yeah, it's a bit of hard work for those people who aren't that sure about sort of low-level management of these things. Like for example, here I'm using this Amos array as my allocated palette buffer. It's convenient from the Amos side because I can just use a Fornex loop and run through the colours. But down here, when I refresh my copper, I need to give it a pointer to this array, so I'm computing the variable pointer here, which is the pointer to this array of element 0. Yeah. Don't worry if you're confused about that. When I look back at it, I'm pretty confused about that. So another one of color functions. Okay, we're just doing some blends of RGB stuff. Not all the demos are interesting, but obviously lots of math functions. This is probably much the same thing. Okay, fixed point cos and sine, polar coordinates. Got obviously a rotate 2D function in there, and just yeah, I'm not quite sure what half of that stuff was showing us, but it's doing it. I guess the key point here is there's library functions to shortcut certain mathematical operations if you want to do them in integer. The library is pure integer, there's no floating point. I guess actually there's no reason why you couldn't use floating point in it, to be honest. It just means that you would have to have a door slam behind me. Very opportune timing. Yeah, the library could have some floating point in it to do rotations, those kind of things. But of course that would mean your system would then need an FPU. So I've got a interpolate step. There's some documentation on the functions on our forum. Off the top of my head, I can't remember them. I'm doing this video in 2017. The last time I looked at the library was about 5 years ago, so forgive me. I just want to make sure that we have videos of all the old projects on our website and for completeness, and I would like to make sure people can actually do something with this, even if it means just giving you the source code and go for it. Fonts are pretty simple, by the way. I think the limitation with fonts is that you have to make a font externally. I think it's just a character dump pretty much, and I don't know if there's a chunky version of that or not. I think it's probably just planar. My gut feeling is that it's just planar. It's got some basic graphic functions. We've got drawing a rectangle, a circle, some lines, some dots. Very rudimentary kind of stuff. The lines are clipped to the surface, and I think all those functions work in planar and chunky. Animation is the next one. 2012 it was. So we've got two buffers, and we're flipping between the buffers to smooth up our animation. Of course, I'm running on an emulator here, and it smooths out the running on the emulator. Whether or not this works on a real Amiga or not, I don't know. It used to. It was written on a real Amiga back in the day, Amiga 1200 with the 68030 in it. But the updates aren't. They're just written on Windows with the IE. Let's get some more interesting stuff below. So animations, then we've got planar dots. Okay, 8-bit planar dot rendering, brute force. So 5,120 dots. Yeah, 10 frames per second in the emulator. I doubt you get that in a real computer. But the key point here is it's just a brute force test. Some of the drawing functions have a simple interface, and they also have like a batch interface. So you could draw a batch of dots or a batch of lines. We've got planar lines, that's the next one. Eight-bit, that's in planar, it's cool. About 30 frames per second. I think we have JIT enabled in UAE, but the examples aren't compiled, obviously, they're just running in AmosPro. I don't know what version I'm running, by the way. I'm not really up to speed about what builds or what. I don't know what this is looking at. Sorry, I should have read what we're meant to be looking at. Ooh, I've got a feeling that hung. Yeah, that crashed. Long story short, that one doesn't work. Okay, so it appears, I think it was custom copper. It's a bit crashy, I don't know why. I have to check the sources to see what's going on with that. Copy Rex. I think this is making like a tile map out of copying blocks from one picture to another. So you could do very basic tile map, sort of scrolling with some basic effects on top. Well, effect is in just drawing a ring of circles. Remap box. This is this is a chunky only effect. And it's kind of for doing those. Well, you can have a pre-computed table with what occurs, and you just give it the table and the source buffer and the out buffer. So you don't actually compute what the blending occurs to the pixel. You just have a table where the source and the blend amount are included, and then it just offsets to find the answer. Star field is the next one. This is a .q example with some more polygon rendering stuff. You can do n-sided surfaces with this. Obviously there's a bit of accuracy with our line and our poly rendering along the edge there. It makes an impressive demo in the in WinUAE. Whether or not it's going to work very well on real hardware, I don't know. Probably not. So we've got gouraud cube. Gouraud 8-bit in Amos. It's a bit rough, but our rotation's a bit rough because the math is integer and the precision level is quite low. I don't remember what it is now. I think it's 16-bit. It's normally I normally use a variable called accuracy. Oh, there you go. It's 8-bit. So it means that up here we're defining this 24-bit whole number part. I don't think that's even true. For memory, 68000 has a 16-bit multiplier, is it? I think the 68020 introduces the true 32-bit multiplier. So I'm assuming Amos would have that same legacy problem, whereas try and multiply value integers that are too large, unless they've added some sort of logic to it. They may well have, I don't know. Alright, that's the gouraud. The torus. Don't think anyone's ever seen this. I hope this stuff captures. Often when I try and capture these things, they just don't really work very well. It's probably very framing. It's running pretty smooth through the emulator. And the way I imagine people using this kind of stuff is actually through WinUAE. I guess these days, if you've got like a vampire card, something that's really screamingly fast, or a 60 out of 60, then yeah, you could probably have a bit of fun. But I guess most of the guys who've got those cards are, you know, fluent with C and assembly programming anyway, can do it themselves. You've probably all seen some great demos in the scene in the last few years. There's two versions of that. Gouraud torus, gouraud test. Well, it doesn't work for whatever reason. Got a couple of versions of dragon. So this is a textured dragon, but it's not sorted from memory. Oh, that might not work. Alright, we just had a problem with the dragon demo. It's going to happen. Things aren't going to work perfectly. That's for damn sure. So we'll try Dragon 2. I wish I remembered exactly what was the difference between each one now. I don't. Oh, well there you go. Obviously testing the gouraud quad at the same time for some reason. You can see that the faces in the dragon actually, from this side it looks kind of okay. The other side you'll see things are sort of drawn out of order because there's no sorting of the polygons. It really does. The original idea was actually to have a kind of sorting engine on the machine code side to do those kind of things. But you know, things change. We'll try Dragon 3. Again, I don't really know what this is going to be. It's kind of more traditional. So we've got the texture itself being rendered on the background, and now you can really see the ordering of the object is not correct from every angle we look at it. That's the sorting of the faces. They need to be sorted. The little pops of accuracy there in the rotation are kind of noticeable as well. It kind of jumps occasionally, but you know, it kind of is what it is. Can't pretend it's something it's not. So some stuff there does seem to be working pretty well. It is not going to be easy for people who don't have a technical background. So probably the people who sort of use this or try and give it a go are going to be those people who have done a bit of coding in assembly, maybe a bit of C work or something like that, or maybe just some low-level Amos stuff in the past. Anyway, so if you want to make a new project, you load up the framework. This is the standard example. You can get rid of all all this jargon up here. Once you understand what you're doing, fine. You don't have to have my name associated with what you're doing. This is just the template I use for all the examples. I think some of these examples are using different versions of the library. Looking at that, it's got AGE version 85. I hope that's the latest version of it. It's hard to tell. The library itself is a wrapper. It's a collection of procedures written in Amos. We'll have a bit of a look at it. Anyway, sorry, before we do that, we'll just jump in here. So our code here, this is the vanilla setup procedure, where we probably could make another wrapped function that just says AGE quick start or something like that, where you don't have to give it any of this stuff here. It just allocates a bunch of presets. Same with the screen here. You might have open screen, fast open screen or something like that. So this example, once we get past the setup here of the library, we are just using our surfaces. We're creating a screen 0, by the way. If you have 10 screens, you'll have screen. Oh, sorry, up here we're saying we've got 15 screens. So they would be indexed as 0 to 15, excluding 15 itself. I can load an IFF image to our preloaded screen. We're creating a copy list for that screen. I'm trying to force Amos to show our copy list. I remember there being some trick about that, and I can't remember what it is off the top of my head now. Obviously, people who are much more up to date with their Amos will be able to jump in there and fix that up. Once your program is finished, it's important that you clean up the library. I don't want to save that. I just want to run the framework. So we've loaded that picture and drawn a few lines on the buffer. Pretty basic stuff. Right, so the actual framework itself, we'll go down a load. No, don't save that thing. We go to includes. This is in our AGE folder. We've got two paths here. We've got a bunch of other files there too. I'm not quite sure what they're meant to be now. The Amos path, this has the library itself, and before we were including version 85. That must be the latest build. And it's really just a collection of functions and a bunch of defined constants. So we're defining some arrays that are used internally by the library. Patch allocate hardware sprite address pointers. Wow. Does a bunch of definitions here of functions that are, oh no, these are our enumerated constants. They're set as globals. Does Amos have constants or not? It may not. This is our register list here, and initialization of the library. Oh, okay. Yeah, sorry. When the library starts, it has to load the machine code into memory and then create a list of the function pointers. Yeah, that's right. And these actually are, these globals here are pointers to functions that are later used to call those routines on your behalf. Down the bottom here, so we've got AGA clear planes, and we'll go to sorry AGE CLS. So it sets up the registers here. It's using something called AGE system base. That's a pointer that we know of, right? That is pointing at the structure that was allocated by the user up front. We set D0 with our screen index. I don't know what that is, so don't ask me off the top of my head. Have a look at the source code. And we just call the function here. Things that return a value would return them in the param system that Amos uses. So some functions are quite lean. Some functions have some code in them. Like this one here is creating a structure and filling it in. Initializing the header of the structure. So there's a fair bit of stuff in the library. You're welcome to poke around with it, modify it, you know, see if you can make it do other stuff. Be my guest. Bunch of system functions for own forbidding tasking. Cleanup function is kind of flushing itself out of memory pretty much. See if I can find the load. Oh, there it is. This is the initialization function for the library. It expects to load a library call, and really that library is just a chunk of machine language that's all PC relative. It's not a normal Amiga library, it's just assembled like that. Really because when I was doing a lot of this kind of work originally, which is a long time ago now, about 20 years ago, I would often use the Amiga and my assembler environment back then to generate code for other devices. I don't want it to be PC relative. I just generate the code, literally save the memory, drop this onto other device, and it would run. That kind of thing. So these kind of libraries are all written that same sort of way, with it, and it does make them pretty ugly, to be honest. Well, yeah, you know, it's pretty ugly stuff. I think it's actually loading the library into memory and doing a bit of a preliminary check to make sure it's kind of has the lib base in it. Core function blocks. Yeah, there's a lot of messing around to get this thing set up. You don't have to do any of this. This is all internal to the library, but just having a look at what's actually in it. At the moment, I mean, I don't be too frightened of it. Anyway, so that's AGE, that's the state of it. Don't expect it to do wonderful things for you, and I think it's, oh sorry, we're in the tools folder, are we? Graphics files there is obviously the folder that has the standard artwork we're looking at all the way through there. It includes is where we have our library files. Manual's probably just some text file, I wouldn't have a clue, mate. And this is a font grab utility, obviously. So have a look at that. Okay. So so you would load a system font and then I guess convert it. I don't know how much of this stuff works. Hit save. Okay. Test font 2017. Let's just try that. Don't know. Did we crash? Or we get stuck in a loop? Well, you might have to. Oh no, we've done something. There you go. This seems a bit slow, that. It's probably all just doing, yeah, I'd say it's probably all just doing everything through Amos there. As in, it's probably just grabbing the font, rendering it somewhere and doing a bunch of, pixel tests. I can't remember. But the code's there for you. Mess around with it, make it work better. All that kind of stuff. So I'll leave that there. Just want to say thanks for watching this monstrosity. Thanks for having an interest in an old project that has very limited use. Hopefully it gives you some ideas. Hopefully you can make something better out of it. Hopefully it gives you a bit of fun. Maybe if you want to pick it up and have a crack on a bit of a go at it, and maybe not. I don't know. Anyway, thanks for watching, and I'll catch you next time. Bye.